Let us see how statistical data is represented graphically. Simply, a heap of data does not tell us anything, so it needs to be processed. Processing involves ranging data in order, classification, and tabulation. Such a compact or condensed form of data is easy to understand. Further, if it is graphically or diagrammatically represented, it becomes simple to understand and interpret. The specific graphs associated with frequency distribution are as follows: histogram, frequency polygon, frequency curve, ogive curve. We will study each of these graphs. So, let's start. Let's begin with histogram. Histogram is a series of adjacent rectangles erected on x-axis with base as class intervals or extended class intervals if required. The height of rectangle is proportional to the corresponding class frequency. But remember, the classes are required to be of same width. See the figure. A typical histogram looks like as shown on the screen. Friends, do you know the difference between bar diagram and histogram? In histogram, there is no gap in between the consecutive rectangles. Also note that histogram is drawn only for frequency distribution. Now let's learn to draw a histogram. Look at the steps. Number 1. Make class intervals continuous if they are not continuous. We call it as extended class intervals. Number 2. Take extended class intervals on x-axis. Number 3. Take frequencies on y-axis. Number 4. Draw rectangles on x-axis with base as extended class intervals. Number 5. Take height of rectangles proportional to corresponding frequency. Let us now try to draw a histogram. Example 1. Following is the frequency distribution of waiting time at ATM center. Draw histogram to represent the data. The number of customers who waited at ATM center between 0 to 30 seconds are 20. 30 to 60 seconds are 28. 60 to 90 seconds are 68. 90 to 120 are 54. 120 to 150 seconds are 10 and 150 to 180 seconds are 3. Solution. Here, the class intervals are continuous. We will take the extended class intervals on x-axis. We will take scale as 2 centimeters is equal to 30 seconds on x-axis. Now, take frequencies on y-axis. We will take scale as 1 centimeter is equal to 10 customers on y-axis. Now, we will draw rectangles on x-axis with base as extended class intervals and height of rectangles proportional to corresponding frequency. This is the desired histogram showing the frequency distribution of waiting time at ATM center. Friends, do you know what are the uses of histogram? Let's see. Number 1. Histogram is used to find mode. It is also used to construct frequency polygon and frequency curve. Number 2. Histogram gives idea about average where it is located. Number 3. It tells us about the spread of data. Number 4. It gives idea about the symmetry of frequency distribution. Number 5. If two different data sets are mixed, then the histogram of such a mixture will have two peaks, that is of bimodality nature. Friends, There are histograms of different types of data. Let's take a look at them. Narrow spreaded distribution, widely spreaded distribution, average, bimodal distribution mixture of data sets, perfectly symmetric distribution, asymmetric distribution, highly symmetric distribution. Friends, think, if we change the class widths for frequency distribution, will the nature of histogram change? If we change the class widths, new frequency distribution will have histogram of same nature. Since there is no change in data, the general nature of histogram does not change.